So if you need to find the inverse of a function, first you can replace f of x with y, and then your goal is to switch the places of x and y and solve for y again. So let's switch their places. Now we've got to get y by itself. If you need to solve an equation where the variable you want to solve for is in the denominator, that should be your first step. So to get that variable out of the denominator, I'm going to multiply both sides by parentheses y plus 2. Because if you first, let's multiply to this side. That's x parentheses y plus 2. The reason why I chose y plus 2 is because when you multiply it to this term right here, these cancel out, getting us our variable out of the denominator like we wanted. Our goal is still to get y by itself, so let's free y out of this jail here and distribute that x. That gives us xy plus 2. 2x. I dropped the x there. That should be an x. Distributive property. So got y out of the parentheses jail. Let's get y from the right side over to the left side by subtracting it. I'm collecting my y's so I can eventually factor out one y from them. That way I can get one y by itself. And so my goal is to keep this left side with only y's. That means this term has to go. I'm going to subtract both sides by 2x. And this is the beauty of getting y's together. Now there's a y in both those terms, so I'm going to factor out a y. You divide a y out of this term, and you're left with just x. Divide y by y, and you're left with just 1. Factor out the y, now I've almost got y by itself. Last step is just to get rid of the x minus 1 by dividing x minus 1 from both sides. There's our final answer for the inverse of the function.